Hi, I'm Gabe Johnson. I'm a PhD student at Iowa State University studying sustainable agriculture and agricultural and biosystems engineering. I'm working with Tom Eisenhart and Michelle Sapir, studying saturated riparian buffers for their design and performance for removing nitrate from tile drainage. Saturated buffers are an edge-of-field practice for improving water quality here across Iowa. How these function is we intercept a tile drainage main that comes out of the field and we reroute that drainage water into a riparian buffer. So what we do is we install this control box here and we put in stop logs to raise the water table and force that water into the buffer zone. What that does is that moves the water. As the water is moving into the buffer zone, it encounters our high carbon, our high organic matter soils, and that provides a chance for a microbial denitrification process to happen, as well as plant uptake by the trees and the grasses here. Some general considerations for siting of these saturated buffers: we generally do not want to back up water into the field in the tile drainage system because that'll cause impacts to crop development, to field operations, and so we like to see a slope as we go back up into the field. We like to see that elevation increase as we move from the buffer into the field. One of the other main considerations, as I mentioned, we raise that water, the water table up into the high carbon, our A horizon of our soils. And so we need to have that carbon present in the soil. We generally like to look for about 0.75% carbon in our soils, or about 1.5% organic matter when we install these sites. In managing and researching these sites, one of the main things we do is we monitor flow coming into our system, and then we also monitor for the nitrate concentration coming out of the field and in the buffer. So at a few points in the buffer we have transects of monitoring wells where we collect water samples from, and then we also collect a water sample from the control box, and that will tell us what that nitrate concentration is coming out of the field. In terms of management of these sites, we have the stop logs. The stop logs that we use to set the water table elevation. So these go down in the control box, and we use that height, wherever these are in the structure, will set that water table. And so this allows us to adjust the flow and how much water is diverted into the buffer. So one of the concerns we might have with these saturated forest riparian buffers specifically is the establishment of our trees after planting. The fortunate thing about the saturated buffer is that it helps us a lot with irrigation and with water for the trees. So as the water goes into the buffer and we raise that water table, we're raising it up into the root zone where it's very accessible for the trees. So especially in the last couple of years with this site as it's being established, the buffer was really important and really useful in providing that extra source of water for the trees, so we didn't have to irrigate. As we've also talked about, one of the other considerations we're looking at out here is those roots from the trees, and if they get down into the tile and if they cause issues. And so that's one of the things we'll be looking at and researching, trying to figure out, is that an issue? And if not, then hopefully we can expand this practice to other areas than where we've traditionally installed them so far. This saturated buffer is a little bit wider than a lot of the other main ones we've seen installed so far around the state. There is a NRCS conservation practice standard for saturated buffers, and there's other practice standards that are involved as well with the forest stand installed here. Generally, the conservation practice standard calls for a minimum width of the saturated buffers to be 30 feet. And this is just to ensure that there's enough space for that water to go into the buffer, and so that we don't cause any issues with stream bank stability if it's too short. However, another notable thing at this site is that the actual buffer area for the forested buffer is a little bit wider than just the saturated area. So the saturated area will extend from this distribution pipe that we have here out to the stream edge, but here at this site we have the buffer extending back up into the field a little bit as well. So as we talked about, this is a research, teaching, and extension site, and so we're trialing out some different things here. So it's not as the saturated forest buffers are new, this looks very different than a traditional saturated buffer for that reason, but also because we're trying some different things with the size, with the orientation of the buffer here as well, and looking at how that will impact its performance and suitability for other sites.